Welcome to the next tutorial. In this tutorial, I'm going to show you how to use SQL join tables to extract data from multiple tables. The reason for doing this is because in many data design scenarios, you're asked to split your data across multiple tables in order to follow normalization rules. And the reason for doing this is to keep your data consistent as much as possible. Of course, as a person who doesn't understand SQL, you may say, well, if I have data in multiple tables, how am I supposed to get the data out? And the answer is by using the join operation. So let's get going, and I'll show you how to do it. Oops. So first just change to the SQLite directory, then SqliteJoinTable join example.db. Now I've already pre-populated this database. Okay, you'll notice I created a table called users, where you have an ID, which is an integer, and a name, which is a string. So I just put in 4 users, J, Ray, K, and May, with IDs of 1, 2, 3, and 4. Then I added a table with phones, and you have the user ID and a number. Now the reason for you having a user ID was to be able to associate a row in the phones table with a row in the users table. You might not do this exactly this way when you design this, a phone book application, but this is to show you how join tables work. Okay, so for example, if we go select star from users, you'll see we get the 4 users, the ID and the name, and if we do the same for phones, then we get the same for phones, and on it goes. Now, so far so good. Now, if somebody asked you which phone numbers belong to Ray, so the first thing you do is you go in the users table and say Ray, okay, there's Ray, and he has a user ID of 2. So then you'd go to the phone numbers table and say, user ID of 2, so it's 8364252 and 2714002. And that's how you would get Ray's phone numbers. Nice to do it by hand, but why not use a program? So the first construct I'll introduce you to is the join, and that's where you go select star from phones, users and phones. Now what you're saying is select all the fields from the users table joined with the phones table. There are different kinds of joins, but this particular kind of join is called the inner join, and that's what we're doing. We'll get more into that later. Now what happens in this query is it takes each row from the users table and joins it with each row from the phones table. So you get 6 plus 6 plus 6 plus 6. You get 6 times 4, which is 24 rows. Let's see what we get. As you can see, 6, 6, 6, and 6. We have 24 rows of data, where each time the first row of the users table is joined with each of the phone numbers, and on it goes with the second, third, and fourth rows. Okay, and you say, that's nice. How's it useful? Well, now you can filter the results. So, for example, you can say, select everything from the users table and the phones table where the user's ID matches with the phone's ID. So you want the number in this column to match the number of this column. And if they don't match, you don't put it in the result. So you think 1J122171882, that should get into your result, but 1J2836452 won't get in the result because the user ID and the ID don't match. Let's see if it's right. And it's right. We're only getting results in this table here where the user.id matches the phone's user underscore ID. Okay, now another way to encode this, now before I say that, conceptually what the engine does is it builds this entire table. Okay, and when running this query right here, it builds this entire table and then filters in the results where the user ID matches the ID. Another way to code the same query is to say select star from users and phones. Now instead of saying where users ID equals phones.userid, you say on user ID equals phone.userid, and you'll get the same answer. Conceptually, what the SQL engine is doing is it is joining the results, and actually it's only joining the results when it first sees a match here. So conceptually, it's not building this huge table. In a lot of relational database engines, it makes a difference in performance, and it's often more efficient to use on rather than where. In SQLite, it makes no difference because under the cover it behaves exactly the same. And in either way, you get the same answer. Now, if you were going to present this information in some sort of a user interface of a program, you don't want all the fields, like ID and user ID, because they're not useful to you. Only the phones and the phone numbers are useful. So you'd say select the name field from the users table and the number field from the phones table, from the users table joined with the phones table, and you also have to say users.id, where the user's ID has to match the phone's user ID. And there you go. You get the same result as here, except instead of selecting star, which includes the ID and user ID fields, you're just selecting the name and the phone number. And look, now you have a nice phone list. You have the name and the phone numbers. You can now take this data and present it in a command line program or a nice user interface. In many data design situations, you're going to be asked to split data across tables and then reconstitute it using join operations. And this is all you have to do. And that ends the tutorial on SQLite join tables. I hope you enjoyed it.